Hello everyone, welcome back to the channel. In today's video, we will create one of the iconic jutsu from Naruto. The person I'm talking about is none other than Kakashi Hatake. We will create his signature move Lightning Blade using shader graph. I'm sure after learning this, you guys will be able to touch your girl's heart. Okay, the end result will look something like this. For this, I'm using Unity version 2023.1, but it will work on any Unity LTS versions. I have a project set up in URP. I also have the post-processing volume with main modules bloom and tone mapping with the mode ACES. And while you guys set up yours, I would like to take a moment as I have hit 300 subscribers and my last video was the fastest one to cross 800 views. So I really want to thank all of you. I really appreciate your support. Okay, enough talking. Now let's get shading. We can break down this effect in two parts, first the lighting and second the core. We will use two separate shader graphs to create them. First, let's start with the easy part, the core. Let's create a shader graph. Right click, create, shader graph URP, and unlit shader graph. Call it Lightning Blade Core Shader. Let's also create a material for that, so keep our shader selected. Right click, create, material. Call it Lightning Blade Core. In our scene, let's create an empty object. Call it Lightning Blade. Let's also create a quad as a child. Call it core. We don't need mesh collider, and assign our core material. In shader graph, go to graph inspector. In the graph settings, set the surface type to transparent. For the core, we will use Unity's default particle texture, so let's directly create sample texture 2D node. In the texture slot, select the default texture. Then take its output and feed it into the power node. Power node will darken the values which are less than 1 as we increase the power. We will control the power from the inspector, so let's create a float property. Call it core power. Give default value of 2. Drag it in and feed it into the power node. Now let's duplicate these two nodes. Take another output from our core power and feed it into divide node. We will divide it with 0.5, then take its output and feed it into the power node. Now we have these two particle texture, one big and one small. We will distort the big one. To do that, let's create a simple noise node. Set its scale to 50. You can of course create a property, but 50 will work just fine. Now if I directly feed this into sample texture 2D nodes UVs, it will distort way too much. So let's create a lerp node. Lerp stands for linear interpolation. It will interpolate between input A and input B based on this input T. If we pass 0 into T, it will output value of A. If we pass 1, it will output values of B. If we pass 0.3, it will output 30% from A and 70% from B. Let's take our simple noise output and feed it into input B. In input A, we will keep original UVs, so create a UV node. Take its output and feed it into A. We will control this T from the inspector, so let's create a float property. Call it distortion scale. Give default value of 0.1. Set the mode to slider, which goes from 0 to 1. Drag it in and feed it into T. Take our lerp node's output and feed it into sample texture 2D nodes UV. Now we will scroll our noise over time, so let's create a tiling and offset node and feed its output into simple noise nodes UV. Create a time node. Take our time and feed it into multiply node to control the scroll speed. we will control the speed from the inspector, so let's create a vector2 property. Call it pan speed. Give default value of -2 and 2. Drag it in and feed it into multiply node. Then take multiply node's output and feed it into the offset. Now we have our distorted particle texture. However, I want the spiky distortion, and for that let's create a polar coordinate nodes. Polar coordinates are circular coordinates where x goes outward and y goes around. So we have x with value 0 at the center and it increases as we go outward. Similarly, we have y with value 1 here, then it goes around, and we have 0 here, then we have -1 here. This center is pretty self-explanatory. Then this radial scale and length scale, think of them as tiling for x and y respectively. Now you guys can see visible seam here because the value just jumped from -1 to 1 here. And if we were to use this as is, we will get visible seam on our distortion as well. To fix it, let's take our polar coordinate node's output and feed it into absolute node. Absolute node will convert every values into absolute values or unsigned values or positive values. Then take its output and split it using split node. Now if we feed x into UV, we will get this ripple effect. We want spikes, so let's feed y instead of x. Then we will add these two power nodes together. Then take add node's output and feed it into the alpha block. Let's create a color property. Call it base color. Set the mode HDR. Give default bluish color. And drag it in. Now we will multiply our base color with the add node. Finally, take its output and feed it into the base color block. In the scene view, we have this nice core, but it's just a 2D effect. So to fix it, I'm going to use this Billboard subgraph. If you want to learn more about it, I will link my Billboard video in the description. In our shader graph, let's drag our Billboard subgraph, take its output and feed it into vertex context position block. Our core shader will look something like this at the end. In the scene view, our core will always look toward the viewport. Pretty cool. Now let's move on to the lightning bolt part. Again, we will use another shader graph for that, so create an unlit shader graph. Let's call it lightning blade bolt shader. We will also create a material for that. Call it lightning blade bolt. In our scene, let's create another quad as child of our empty. I will call it lightning. Then assign our newly created material. In our shader graph, go to Graph Inspector in the Graph Settings. Set the surface type to transparent. To create lightning bolts, we will use triangle wave. They are similar to sine waves, but their shape is triangular. For that, let's create a triangle wave node. It will output the triangle waves with values between -1 and 1 based on the input we feed. Let me just quickly demonstrate it. So I will take tiling and offset node, set tiling as 5 for both x and y, split it, and if I feed x, we will get vertical waves. If I feed y, we will get horizontal waves. Now we want our bolts to go outward from the center. For that, let's create a polar coordinates node. Take its output and feed it into the split node. We don't need this tiling and offset node. Now we can control the number of bolts with this length scale. We will control this from the inspector, so let's create a float property. Call it bolts. Give default value of 5. drag it in and fade it into length scale. I will also like to have an ability to rotate these bolts, and we can easily rotate them by adding some offset to our Y. Now we can rotate our bolts by adding values. We will do that from the inspector, so let's create another float property, call it angle, drag it in and feed it into the add node. Now to control the width of our bolts, we can use power node. But if we directly feed our waves to power node, we will get NaN or not a number error where the values are less than 1. So to fix it, we will use saturate node. It will clamp the values between 0 and 1, then take its output and feed it into the power node. Now we can control the width. We will do that from the inspector, so let's create a float property, call it bolt power, give default value of 20, drag it in and feed it into the power node. Let's also create a color property, call it base color, set the mode HDR, give default color and drag it in. We will multiply our base color with our bolts, then take multiply node's output and feed it into the base color block. Also take power node's output and feed it into the alpha block. Now if we look at the scene view, our bolts abruptly ends at the edges of our quad, which is not nice, so let's fix that. We will fade the bolts from the edges, and for that let's create another polar coordinates node. Take its output and feed it into split node. We will use X. It will have value of 0 at the center and it increases as we move outward. We want opposite of that, so we will take our X and feed it into 1 minus node. 1 minus node, as the name suggests, subtract whatever value we feed in from 1. Now we have this nice circle. We will control its size with power node, but first we will saturate it for similar reasons I showed you earlier with bolts. Then we will multiply these two together. Then multiply it with our base color. Also take its output and feed it into the alpha block. Now let's distort our bolts. We will use simple noise for that, just as we did for our core part. We will also scroll this noise over time, so again, similar to what we have done earlier in the core part. And our bolts look like lightning bolts. Now for the edge blend here, I want it to ping pong between two values over time. For that, we will create two properties. First, float property to determine how quickly it ping pong between two values. I will call it edge blend speed. Give default value of 20, drag it in. Second, vector2 property to determine the min-max range. I will call it edge min-max. Give default value of 2 and 5 and drag it in. Now we will multiply our edge blend speed with time. Then take its output and feed it into the sine node. Sine node's output values will ping pong between -1 and 1. We will remap them, so take its output and feed it into remap node. Remap node, as the name implies, remap these values which has original range from -1 to 1, and we will remap them with edge min-max. Finally, take its output and feed it into the power node. We will also use our Billboard subgraph, so our effect will always face towards the camera. That's it for our bold shader. It will look like this at the end. In our scene view, let's adjust our materials and quads. Now it looks pretty cool, but I want to change the number of bolts and its rotation after fixed duration of time. For that, let's create a simple script. Let's call it lightning bolt settings and assign it to our lightning game object. In our script, let's define two fields for our minimum and maximum bolt counts. One more float field to define our change duration. Lastly, we will grab the reference of our material. Then let's create a method to change the angle and bolt counts. Let's call it change material values. Let's get a random bolt count using our min-max and grab it into a variable. Let's also get a random angle between 0 and pi. Finally, let's set these values to our material. Now we need to call our method repeatedly, and I'm going to use invoke repeating method to do so. So in a wake method, I want to repeatedly call our change material values method after this amount of duration and want to repeat it every this amount of seconds. Then in the inspector, let's assign our material into material slot. So we will change bolt count randomly between 3 and 7 with random rotation after every 10th of a second. And that's it. We have our lightning blade effect. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. If you have any questions, suggestions, opinions, let me know in the comments. That's it from me, and I will see you guys in the next one.